Hello everyone, welcome to OpenMP SC21 Boot Talk series. I'm Swaroop Pophale, a computer scientist at the Oak Ridge National Laboratory, and I'm going to present our ongoing effort on the SOLVE OpenMP validation and verification suite. Let me introduce you to our team, which comprises of Oak Ridge and University of Delaware personnel. This is the outline of my talk. I will introduce what the ECP SOLVE project is all about, then talk about the scope and intent of the validation and verification suite. Starting with specification 4.0, OpenMP introduced the offload model, which basically allows for execution on devices such as GPUs. With that, it introduced many new features, and we will focus on the 5.0 and 5.1 new features. Then I will talk about the test design process in the validation and verification suite, as well as the infrastructure of the test suite. I will also show a result snapshot, as well as discuss some success stories that we have had so far. And finally, I will conclude with ways to collaborate, as this needs to be a collaborative community effort to get the best testing process in there. SOLVE stands for Scaling OpenMP with LLVM for exascale performance and portability. The SOLVE ECP project consists of many parts, be it the specification development, compiler development, runtime enhancement, and the validation of quality and performance of the OpenMP features. SOLVE proposes an application-driven approach that requires us to interact extensively with ECP applications to systematically obtain their input and feedback and to ensure that we respond effectively to their needs. We engage with key vendors, relevant ECP co-design centers and SD teams, and the broader OpenMP community in order to obtain the best possible solutions to ECP application problems. So what is the scope and intent of the validation and verification suite? So the suite verifies the status of OpenMP implementation across ECP platforms. This is not tied to a specific vendor, and as such, you can use the validation and verification suite with any OpenMP compiler. It is also used in evaluation of the OpenMP functionality and the performance on target architectures. We check for implementation's conformance to the OpenMP standards, and the tests and kernels are primarily motivated by the ECP applications. The end goal is to verify that a platform is ready for the specific OpenMP applications. Once they run the validation and verification suite and see the results of it, it gives a fair idea of where each implementation is in terms of supporting features and having the latest spec supported. Starting with the OpenMP 4.0 specification, OpenMP introduced the device offload machine model. The directives introduced enable you to offload data and computation to devices such as GPUs. This makes it easier to write portable heterogeneous parallel code, as well as lets you free up the CPU while computations run on the GPUs. At the end of the computation, you can copy the data back to the CPU. Now let's look at some of the new features introduced in 5.0. These include context, meta directives, and declare variant. Declare variant was particularly important because applications did not want to write the same code again and again for, say, the host as well as device. Declare variant allows for choosing of different directives in the context that is selected. Addition of requires directive, including support for unified shared memory, memory allocators, support for deep memory hierarchies, descriptive loop construct are some of the other important features introduced. Loop construct is particularly flexible as it does not require you to specify details because the compiler will know the hardware it is running on and give you the best possible decomposition for the loop construct. The release acquire semantics were added to the memory model, as well as OMPT and OMPD support was added. The completed support for Fortran 2003, as well as support for various C standards as well as Fortran was added in 5.0. In 5.1, there is a long list of modifications and additions that were made. I will just talk about a few of them, like the OpenMP, OMP All Memory Reserve Allocator, as well as the Target Device Trait and the Target Device Selector. The Dispatch Construct, the Assume Directive, Nothing Directive to be used with meta directives was also added. The device-specific ICV support gives more control to the user when a specific class of device is used. The error directive was introduced, which is particularly important if user wants to add some specific errors in certain conditions, which was not possible before. The mask construct has replaced the master construct with mostly the same features, and we have the loop transformation constructs and the scope directives for use. Other than that, OpenMP 5.1 adds the C++ attribute specifiers support, as well as full support for Fortran 2008, C11, and thereon. So now let's look at the V&V test design process. So when we analyze an application or a new OpenMP directive, we formulate a test, we discuss it amongst our team to see if there is anything we missed in the test. If the test is valid, we move on with testing it with available implementations. Sometimes implementations are not available because the specification is just out and the vendors have not caught up. In that case, we have to make our best guess and then come back to the test and verify that it works with everything, all compilers, after an implementation is available. So there are three basically good outcomes of this process. One, we sometimes find ambiguities in the specification, the wording, the language, and we take it to the OpenMP specification board, languages committee, and discuss that. If through the test, we find any bugs in the vendor compilers, we file those bugs with the vendors, and in the past, we've seen quick responses to resolution of such bugs. And once we verify that everything is correct, that goes in the V&V and it is made available to everyone. So a little more about the validation and verification suite infrastructure. Our infrastructure is based on Makefile and scripts. There are design parameters to provide portability across multiple compilers and systems. We support different compiler options, and we have Lua-like modules and batch schedulers. This enables for fast test addition and modification. It divides the compilation and the execution phases, and you can also have it such that a subset of tests is selected for partial execution. Now let's look at the directory model of the V&V. So the test suite has 4 main directories, which is the tests, all our valid OMP V&V header files in their system, and template. Templates will have different scripts that you might copy. For example, we have a Summit def file, which has parameters that are relevant to the Summit supercomputer, as well as Cori and Spark as our recent additions. Now in the test directories, we have divided the tests according to the specification version. So 4.5 specific tests are obviously in the 4.5 folder. 5.0, the delta, the new things that have been introduced in 5.0, you can find that in the 5.0 folder, and so on and so forth. So sample results, we periodically run the entire test suite on different compilers and relevant ECP platforms, and those results we present on this web page. So here you will not only see what tests have passed and failed, you can also click on a particular result to see what the compiler response was. So this is particularly important when you want to see where it failed, or what did the compiler, what was the output of the compiler or the runtime when a particular test failed. And you can click on the green or the red pass and fail and see what exactly was the output at that time. Now I'm going to give you a result snapshot. This is a recent result snapshot from, this is the data derived from the test pass-fail from our website. And as you can see, Summit and Cori, these are the different compilers that have been implemented. Unfortunately, Fortran is way behind the curve as compared to C and C++. But we are seeing that on Spark, Clang and Cray are showing very good improvement over time with our V&V. And that is one of the parameters of checking how an implementation is doing. As time progresses, we have seen that more and more V&V tests have passed on certain compilers which are under development. So let me share some success stories with you. Cray and AMD are actively using the SOLLVE V&V to verify correctness in their 4.5 and ongoing 5.0 development effort. We have vendors such as GCC developers actively engaging with us to improve our coverage in the V&V, and also we have found bugs that have been worked on. So implementation bugs that have been identified in GCC, IBM and Cray, we have brought it to the vendor's attention, and most often than not, we've found that they have responded very positively to this. OLCF, which is preparing for Frontier, is using the SOLLVE V&V as their acceptance, one of the acceptance criteria. And NERSC has also integrated the SOLLVE V&V for testing OpenMP implementations. So how to collaborate? We have a GitHub site where anyone who's interested can download this V&V, and you can log issues, you can create pull requests. So that is what we want. We want the community to get together and get more involved. We are talking with the applications, but we are talking with ECP applications, sometimes car applications, but we also want to know what the wider OpenMP community needs. So if you need to check a behavior of your OpenMP application, you can create an application kernel and submit a pull request, and we can include that kernel in our tests. That way, by running the test suite, you know if an implementation is ready to handle your large-scale application. If you found something that we missed, then you can submit an issue or create a PR if you know the solution, and give it on the GitHub, and we will definitely respond to it. So here is our contact information. Please feel free to reach out to any of the team. We all are in regular contact, and we will get back to you as soon as possible. Last but not the least, I would like to acknowledge the US Department of Energy and the Exascale Computing Project, which has supported the SOLLVE effort. Thank you so much for attending this talk, and if you have any questions, please feel free to reach out.